The actual amount of instant coffee that a filling machine puts into 4-ounce jars is normally distributed with a mean of 4.082 ounces and a standard deviation of 0.04 ounces. Number 1, define a random variable x suitable in this context. Well, what's variable is the amount that's actually put in the jar. Even though the jar says there's 4 ounces, there's actually, on average, 4.082 ounces. So a little bit more with a standard deviation of 0.04 ounces. So in any case, the variable is the amount of coffee actually in the 4-ounce jars. So the amount of coffee in a 4-ounce jar. So, in ounces. Number 2, x fits what distribution? Well, according to the paragraph or the sentence here, it says that we have a normal distribution with a mean of 4.082 and a standard deviation of 0.04 ounces. Number 3, find the 10th percentile of fill weights. So this is the number for which only 10% of jars is less than this number, so less than this weight. So we can sketch a graph to help us decide what's going on here, get an estimate for our answer before we go to the computer and ask. The mean is 4.082. We have a bell curve because it's normal. And the standard deviation is 0.04, so this number right here is about 0.04 less than this, so we're jumping by 0.04 to the one standard deviation away, so that's 4.042. That's getting a little sloppy. Okay, and then over here we jump one more standard deviation and we're at 4.002. Okay, and we're interested in the 10th percentile. That means we need a line where 10% of the area is to the left of that line. So I'm going to draw my line right about here and say that the answer is somewhere between 40.02 and 40.42. So what exactly is that? It's about maybe 40.22, something like that. So we can go on the computer now and ask for the 10th percentile. So the 10th percentile in GeoGebra is the inverse normal with arguments equal to the mean. I'm going to run out of room here. The standard deviation and the percentile we're looking for, so 0.1. Okay, now we flip over to GeoGebra and put that in. GeoGebra, okay, that's from last time, we can get rid of that. So we want inverse normal with a mean of, what was the mean? Let's see. The mean was 4.082. The standard deviation is 0.04, and the probability we're looking for is 0.1. So 4.0307. So according to GeoGebra, this number is approximately 4.0307. 4.0307. And our estimate from from the graph was about 4.022. That's not bad. 4.03 is right here, so that's a pretty good estimate, and that means we can believe our answer and call it a day.